Good morning, everyone. So I want to look at one more short topic. Now that we know the power rule, I want to go back and revisit the idea of the tangent line that we looked at the very beginning of this unit. But instead of finding the tangent line in the way that we did before, I want to just use our simple power rule in order to find the derivative and then use that derivative to find the equation of our tangent line. So let's go ahead and look at a few examples. All right, so this is going to be much quicker than the way that we did it before. All right, so let's say to start with, all right, we're just trying to find the equation of the tangent line to the graph of the given function at the given point. So let's start off with something simple. Let's say we have f of x is equal to 2x squared plus 4. And the point that I'm going to give you is 1, 6. Okay, so we're trying to find the equation of the tangent line to the graph of the function at the given point. So whenever you're thinking about a tangent line, you need to be thinking about derivatives. So remember the tangent line, and if you just think about this graph for a second, let me just draw a quick sketch here. All right, so we've got a quadratic function, and you don't have to graph it. I just kind of want to give you a visual just to remind you what we're looking at. All right, so we have a quadratic function, something roughly like that. We're saying we have this point over here at 1, 6, and we're trying to find the equation of the tangent line. So remember, the goal is we need to find the slope of the tangent line first. And whenever you're thinking about the slope of a line or the slope of a function at a given point, you're thinking derivative. Remember, the derivative is finding you the instantaneous rate of change or the slope of the tangent line at any given point on a function. So now that we have the power rule, finding the derivative is easy. So that's what we're going to do first. Okay. All right, so for this function, if we think about finding our derivative, this is just simple power rule. All right, so power rule says basically we take our 2, bring it out front, multiply it by anything that's already there. So in this case, 2 times 2 would give us a 4 out front. And then subtract 1 from our exponent, so 2 minus 1 is just 1. Okay. And then remember, the derivative of a constant is always just 0. Okay, so in this case, our derivative is just 4x. Okay. All right, so now that we have the derivative, we want to use it to try and find the slope at this given point. So all we need to do is plug in our x equals 1. Right, so the slope of the tangent line is just going to be f prime of 1, which is just 4 times 1, or 4. So the slope of this tangent line is 4. Okay. Well, remember, whenever you're looking at the equation of a line, you're just thinking y equals mx plus b. We just found that our slope is 4. So the only thing we still need to find is the y-intercept. Well, that's easy. We can just plug in our point. So we would have 6 is equal to 4 times 1 plus b. And if we solve that out, we end up with b is equal to 2. So putting it all together, the equation of our tangent line is y is equal to 4x plus 2. So that is our final answer. Okay, so now that we have the power rule at our disposal, finding the equation of a tangent line is a much quicker process than it was before. All right, let's go ahead and take a look at another example. All right, so let's say we have f of x is equal to x to the 4th plus 7x all over x. And I want to find the equation of the tangent line at the point 215. Okay, well, on this one, the first thing we're going to have to do is simplify this function, because as it is right now, it's a quotient, And we don't have any rules yet to help us find the derivative of a quotient. All we have is just our power rule and the constant multiple rule that goes along with it, the sum and difference rules that go along with it. But we don't have anything that deals with a fraction yet. We will, but we haven't gotten to that yet. So we just need to go ahead and just simplify this. But because we only have that one x in the denominator, that's going to be easy. We can just sort of split this fraction up. So this is just going to become x cubed plus 7 if we simplify that f of x function. All right, so now we can find our derivative then. All right, and again, this is just simple power rule. So bring our 3 down, subtract 1 from our exponent, and once again, the derivative of a constant is just 0. So our derivative is 3x squared. All right, so now we want to find the slope of the tangent line, which is just the derivative, at the given point, which in this case our x value is 2. So the derivative at x equals 2. So just plug that in. That's going to be 4 times 3, so that gives us a slope of 12. And then again, just remember the equation of a line is y equals mx plus b. We just found that our slope is 12. So then just plug in your point and solve for b. All right, so we're just going to have 15 minus 24, which would just give us a negative 9 for our b. So putting it all together, y is equal to 12x minus 9. Okay. All right, guys, so that's basically all I wanted to show you in this video, is just so that you could see that now that we have new rules for finding a derivative, we also have new rules for finding a tangent line. So you can use these properties to help simplify that process of finding a tangent line, just like you can simplify the process of finding a derivative. So basically from here on out, if you're asked to find the equation of a tangent line, don't do it the long way with the limit process, but instead do it the short way with your derivative rules.